All right, let's get right into it. We're about to pull back the curtain on the silent, invisible technology that's powering literally everything you do online. It's a massive revolution, and it's happening inside tiny threads of glass, running beneath our streets and across the bottom of our oceans. So, for this whole breakdown, we're going to be leaning on an absolutely fantastic and super detailed article called Light as Information. You can find it on n.techfocus.rs, and seriously, it covers everything.
Okay, so let's start with something we all get. You hit play on some gorgeous 4K movie, and it just works, right? Instantly. No buffering, no ugly pixelated squares. How in the world does that happen? Well, it's not magic, it's pure physics.
And this is the hero of our story, the optical cable. Now, this thing isn't carrying electricity like you might think. Nope, it's carrying something way, way faster. It's basically a tiny, super flexible thread of glass, incredibly pure glass, that's flashing these little pulses of light. And those flashes, that's your movie, that's your email, that's literally all the ones and zeros that make up your entire digital life. But here's the crazy part. This revolutionary idea, it's not actually new. In fact, its origin story starts somewhere you would never guess, a simple water fountain from way back in the 19th century. So check this out. This is the aha moment. On the left, you've got that old experiment. See how the light gets trapped inside the curving stream of water? It just keeps bouncing off the inside, refusing to escape. Well, that incredible little physics trick, it's called total internal reflection, and it's the exact same principle we use today in the modern optical fiber you see on the right. The light is literally just ricocheting its way down a tube of glass for miles and miles. Of course, getting from a cool water trick to a global network took some time. The real breakthrough, the big leap, happened in the 1960s. A brilliant scientist, Dr. Charles K. Kao, had this theory. What if we could make glass so pure that a light signal could travel through it for miles without fading? It was just a theory, until 1970, when the folks at Corning Glassworks actually did it. They made his theory a reality, and the first true optical fiber was born. All right, so now we've got this amazing new technology. But it had to go up against the reigning champ of communication, right? Good old electricity zipping through copper wires. So you've got light versus electricity. And, well, it turned out to be a total knockout. I mean, it wasn't even close. When you put them head to head, light just dominates in every single category. Optical fiber can carry an insane amount of information. It can go for much longer distances. It's way more secure. And, this is a big one, it's completely immune to all that electrical interference that can mess up a signal in old copper cables. And this chart really just spells it out, doesn't it? We're not talking about a little bit better. It's a whole different league. Optical fiber is cruising along in terabits per second, while poor old copper is stuck back in the world of megabits or maybe gigabits. And the range? We're talking tens, even hundreds of kilometers before a signal needs a boost, compared to about 100 meters for a typical copper Ethernet cable. It was, and still is, a complete game changer. All right, so we've established it's powerful on a micro level, but now let's zoom way out, because the true scale of this tech, it's just staggering. We are talking about a network of glass that literally wraps around the entire planet. So, on its own, a single beam of light in a modern fiber can go for incredible distances without any help. So, you've got different types of equipment for this. A standard long-range, or LR, module can push a signal about 10 kilometers. An extended range, or ER module, gets you up to 40, and a ZR can go all the way up to 80 kilometers, which is amazing. But what happens when 80 kilometers is just a drop in the bucket? You know, like when you need to cross an entire ocean? Well, this is what you do. You build this. A massive, intricate web of submarine cables that are the real backbone of the internet. And to make it across those thousands and thousands of kilometers, that little pulse of life, it's gonna need some help along the way. And the way they do it is just brilliant. Every 60 to 100 kilometers or so, sitting there on the ocean floor, the fiber goes through a special box. It's an amplifier, called an EDFA. Now, the clever part is this. Instead of converting the light to electricity and then back again, which is slow and complicated, it just boosts the light as light. It's almost like giving a swing a perfectly timed push right as it starts to slow down. It just re-energizes the signal so it can keep going for another 100 kilometers. Okay, so we've been talking about this huge planet-spanning network. Let's zoom right back in, down to the level of a single technician. Because building and maintaining this network, yeah, it's not like plugging in a lamp.
It takes an incredible amount of precision and a whole toolkit of very specialized gear.
I mean, just think about it. You are working with a piece of glass that is thinner than a single human hair. So you need special strippers just to get the coating off. You need a cleaver, often with a diamond blade, to cut it at a perfect 90-degree angle. And then you need this incredible machine, a fusion splicer, that zaps it with an electric arc to melt the two ends together perfectly. It's not just tech, it's high-tech craftsmanship.
So why does any of this matter? Okay, faster movies are nice, sure. But this invisible network of glass is about so much more than that. It is literally the foundation for everything that's coming next in our world. And this isn't some far-off future thing. This revolution is happening as we speak, and it's speeding up. Just look at this number. In Serbia, which is one of Europe's fastest-growing markets for this stuff, the number of homes getting hooked up directly to fiber grew by more than 26% in 1 year. That is explosive growth, and you're seeing that trend all over the world. Just think about all the buzzwords you hear every day, right? 5G, the cloud, artificial intelligence. What do they all have in common? They have a completely insatiable appetite for data. They need speed and capacity that is just unimaginable. And the only thing that can feed that hunger is a fiber optic foundation. It's simple. Without fiber, none of these incredible innovations can actually work at the scale we need them to. And that brings us back to our source article from TechFokus.rs, which just nails it with this quote. Optical infrastructure is the only medium capable of sustaining global data growth. It's not just a better option anymore, it is absolutely essential. So, when you put it all together, is the future really, truly optical?
Yeah, absolutely. There's no question about it. It's the plumbing. It's the bedrock. It's the one thing that the entire next generation of technology is being built on right now.
Look, we've really just scratched the surface today. If you want to dive way deeper, get into the nitty-gritty of the standards, the different connectors, all the tools, I really recommend you go read the full original article that we based this whole explainer on. You can find it over at n.techfocus.rs. Thanks so much for tuning in.